The limit, as h approaches 0, of f of a plus h minus f of a all over h is the derivative of f of x at x equals a, denoted by f prime of a. It's also the slope of the curve y equals f of x at x equals a, the slope of the tangent line at x equals a, and the instantaneous rate of change of f of x at x equals a. This limit, when it exists, has 4 different interpretations that are all trying to tell me the same thing. I thought it would be nice to work an example from the book where I might be able to start putting some of these ideas together. On page 124, we find problem number 24. The effectiveness of a drug. On a scale from 0 to 1, the effectiveness E of a pain-killing drug T hours after entering the bloodstream is displayed in the accompanying figure. At what times does the effectiveness appear to be increasing? What is true about the derivative at those times? Part B, at what time would you estimate that the drug reaches its maximum effectiveness? What is true about the derivative at that time? What is true about the derivative as time increases in the 1 hour before your estimated time? All right, just so it's easier to see, I've translated some of that onto this board. I've only written the first part of each question. We'll go back and make sure we answer the calculus part. What we have here right now, ignoring the ... where the author asks us to include the calculus, are really just some algebra questions, some concepts from an algebra course or a pre-calculus course in your FAST. At what times does the effectiveness appear to be increasing? Well, a function is increasing when it goes up from left to right. When the domain goes up, the y value also goes up. So on this function, I'm going up from left to right on the interval from 0 to 3. All right, so I'm increasing from 0 to 3. Of course, I could tell you we're decreasing from 3 to where the domain ends. In your author's diagram, it looks to end just before 5, but he only asks about the increasing. Now going back to the rest of his question here, what is true about the derivative at those times? So he's asking me to look at this diagram and tell you something that's true about the derivative of the function during those times. And so we have to think about it, and I think about my different interpretations. A derivative is the slope of the curve, the slope of a tangent line, and the instantaneous rate of change. So I want to think about slopes of tangent lines. And so on the interval from 0 to 3, I could take a point here, and I could imagine drawing the tangent line, right? That line that just touches my graph in one point near the point on the graph, right? It might go through the graph somewhere else, this one won't. But that slope, the slope of that tangent line is the slope of the curve is the first derivative. And so let's just do that at a couple spots here, right? These little tangent lines. And on the interval from 0 to 3, what I would tell you about these tangent lines is they all have positive slope. They're all going up from left to right. The derivative, the slopes of the tangent lines, are positive on the interval from 0 to 3. So that's the big claim. That's what your author is trying to get us to put together with what we know so far, is that as my function is increasing, it looks like my tangent lines are all positive. All right, so part B here. At what time would you estimate that the drug reaches its maximum effectiveness? Well, I'm increasing and then I'm decreasing. I think the highest ranking I see right there is, well, the highest ranking I see on the whole picture is right there at 3. Right there, the idea of relative maximum from maybe a pre-calculus course, right? The thing at the top of the hill, right? And so there I have my relative maximum. Of course, the author asks us a further question in the ... that I've written there. And he asks us, what is true about the derivative at that time? All right, well, for the first part, I was thinking about little tangent lines, and I think that's okay there, too. And I tangent to the curve, well, that's what I think the tangent line looks like. I think the tangent line's horizontal right there. The slope of a horizontal line is 0. I think the derivative is 0. All right, and then the last little bit of the question that the author asks is, what is true about the derivative in the 1 hour before the maximum? Right, so as we go from 2 to 3, what's true about the derivative? Well, I already have some little tangent lines drawn, and there's one, and there's another, and then that's the last one. And what I see is that one's positive. That one's not quite as steep. It's positive, but it's less positive. That's a very weird way of saying it's a less, right? This kind of has the highest slope on the interval. That one's less, less, and then 0. They're all positive, but I think they're decreasing. From 2 to 3, the derivative appears to decrease. All right, so there's a nice application question where your author has us think about, hey, this idea of increasing and maximum and what it might have to do with derivatives. On the interval where I was increasing, it looks like my derivative was positive. He could ask us to think about the derivative on the interval where we're decreasing. And what I would see is a whole bunch of tangent lines that look like they're going down from left to right. On those intervals, I think my derivative is going to have to be negative. At the top, where I have that maximum value, I had a horizontal tangent line, a slope of 0. We're going to revisit all of these ideas later on in the course. Here on page 124, we're just kind of getting used to them. Bye for now.